Okay, so we're inside the atmosphere of a cold ice giant. Now, the really interesting thing about the shadows of the rings around it is that they have some weight with their dust configurations. And I'll be moving on the above the lower atmosphere with the upper atmosphere visible directly overhead. And the thing is that there's an envelope of details that the rings are actually not directly casting a shadow onto the lower atmosphere, but being absorbed. And the thing about it, if we move up now, higher up, and we notice that the lines configure as though there was some kind of depression ahead, meaning basically that the atmosphere below the ring shadows has to be compressed in some way downwards by perhaps the absorbance of heat by the molecules in the ring structure, thus creating a thermal weight envelope that looks a lot like space-time being warped ahead. And now we are observing cold Selena and another cold Selena. You actually see the ring structure straight ahead out in space, where the actual dust particles are, and an angle to the curvature of the gas planet, and a lot of variables with different effects, and probably because it's the light of the galaxy streaming through the rings that is illuminating the upper atmosphere. And if we move up a little bit more and we start to notice that most of the gas it looks like it's being depressed into the lower atmosphere by some kind of force of light that's actually making an indentation, much like you'd place a heavy tube on a bed. And the thing about this is that it's not only space-time being affected, but let's see. It's all the lower cloud layer, so there seems to be some kind of ratio between the lower cloud layer and the upper. And so let's go deeper into the atmosphere and into the projected depth. And you can actually see If we align this with the galaxy background, just take a dip. And there we go. It seems like we have layers upon layers of filtrated light and shadow from the galactic light, and the surface. I think I'll try and go through it, and here we have another layer. So I'm guessing that each atmospherical layer has a different way of filtering out the ring light and shadow. This is much like going through a tunnel. Or like a cave, where all the lines of shadow and light are actually focusing on one point. If we want to find that point, we'd have to move. We'd have to move pretty fast. Which seems to be the velocity of the curvature has something to do with the layers, their height, and the circumference, and the shadow and light play. Much like it's being hollowed out, you know? Like, here we go. This is the bulbulus. This is the section that is pressing down on the bulbulus, creating a concavity. And this is the other bulbulus side. Let's see. The rings are an angle. Let's say the rings are vertical and the shadows are at an angle, meaning there is some kind of focus point. Look ahead. Let's see. When we try to move along, you can actually see the opposite effect. We're looking for the rings and the horizon, the edge of the planet. What's interesting is that I'm going to try and get into the inner edge and then of the ring. So we're kind of developing a spatial light effect. Now this is the width of a ring that I'm going over, and it is it's very long actually. Just see. Alright, there we go. Now that's the inner edge of the rings, and let's try to see back on it and down to its origin. So it thins out. It goes from a point to a width. The central width narrows down and goes into a point at the horizon somewhere. and that's from the side. This is the right side, and we can see it down to the point where it verges and expands, or rather curves. So the width depends on actually the inner radius is much like the point where the edge, seen on edge, can also trace a path in front of us there, that thin line. There we go. Now that's, let's see if we can move to it. Now it's creating a surface of light and shadow in reference to the background galactic light. So we have X and Y. Let's say we're on a mesh of space-time, but this mesh only has, let's say, X values on its surface. But it's still enough. It's the basics of being able to skim over it and pretend that we're moving on a flat surface, perhaps as much conserved in space as it is for the gas planet in its size. Alright, hope that was interesting for you.